No, is that?
That's fine.
Let me sneak past you. Sorry. All right, I will begin with a word of prayer. Heavenly Father, we thank you for the weekend just completed. Thank you for these students. Just ask you just bless our work today. Help us to just learn more about your creation and to glorify you in what we do, Lord. In your name I pray, Lord Jesus. Amen. So today I'm mostly talking about absolute value. I mean, that's not all we're talking about, but it's certainly the theme of today's lecture. So to start with, you guys tell me, what's the absolute value of x? What is that equal to? It's what? X? Nope. Mm-mm. 1? No. X or minus x, I'll take that. It is equal to plus or minus x, that's true. Specifically, it's minus x if x is less than or equal to 0, right? And it's x if x is greater than or equal to 0. So, I mean, this is in fact what's known as a quote-unquote case-wise defined function, right? Depending on what case you're in, use a different formula. Now, there is a sneaky one-size-fits-all algebraic formula for this thing. It is the square root of x squared. Now, you might not believe me that that's the formula for absolute value of x. So in the interest of convincing you, let me show you two examples. Example 1, absolute value of 4. Square root of 4 squared. What is that? Well, that's the square root of 16, which of course is 4. How about the absolute value of minus 4? Yeah, the square root of minus 4 squared, which is the square root of 16, which, like you just told me a second ago, is 4. So this formula, square root of x squared, is just, it's a convenient formula to describe what absolute value of x is. All right? Now, what are the properties of absolute value of x? Well, certainly it has a few properties. It's almost as important to know what it doesn't do as opposed to what it does do. Probably the most important property to notice is that the absolute value of x is greater than or equal to 0. Right? So absolute value is non-negative. If somebody says to solve an equation that's got absolute value equal to a negative number, well, your job is very easy. You tell them to go fly a kite, you know, or whatever. No solution to that one. On the other hand, if we look at the absolute value of x times y, that would be the square root of x, y quantity squared, which would be the square root of x squared, y squared. And then by properties of the square root function, that's the square root of x squared times the square root of y squared, which is, lo and behold, the absolute value of y times the absolute value of x. So, in short, the absolute value of a product is the product of the absolute values. That's a nice thing to know about. What's another nice thing to know about absolute value? What does absolute value do to minus? Yeah, it just gets rid of it. Now, it doesn't just make it x, it makes it the absolute value of x, right? That could be plus or minus x. For example, if x is minus 5, it's minus a minus 5 that the absolute value is equal to, right? You know what I mean?
Oh.
Like the absolute value of minus 5 is equal to 5, right?
So if x is anything less than 0, it just becomes positive?
Yeah. So what's another way we could talk about absolute? What is it in terms of like geometry? What is this? This is what? This is the distance of x on number line, right? From where?
0.
From 0, right. That's another way we could think about absolute value of x. It's the distance from 0 to x on the number line. So distance has to be positive, so yeah. Now, there's one thing we definitely can't do. Well, let me not say we can't do it. Let's try it. Try this on for size. Absolute value of, I don't know, 7 plus minus 3. How's that go? Well, if that's the absolute value of 7 plus the absolute value of minus 3, that's 7 plus 3, which is 10. But on the other hand, that would be the absolute value of 4, which would be equal to 4. So 4 equals 10. Where's my error? Which of these steps is forbidden. There are many things that are true. You know, the side, like the parts on the side are true. There's one very wrong.
The -3 by itself.
What's
Remove the -3 from the equation already.
no, I wouldn't say that's it. Now, how about the oh, it was you, not me. I was like, I thought I dropped something, and then the sound was like way over there. I was like, what? But so the error here is right here. That's just not true. You see, the absolute value of x plus y is not equal to the absolute value of x plus the absolute value of y. This is just not usually true. Well, it could be true if x and y are both positive, but if one of them's positive and one of them's negative, they cancel each other out, and you just don't get equality here, like I show in my blue example, right? My blue example is a cautionary tale. Don't do this, right? Let me put a big old no. All right, can't do that. So what I'm trying to tell you is with absolute value product of the absolute values, just fine. Kills minuses, great. Its value is non-negative, fine. But we can't break up sums like that. It just doesn't hold true. So let's look at some examples. Let's try to solve some absolute value problems. How about 3x minus 7 equals to, oh, I don't know, 1. Can we solve this equation involving the absolute value? Let's see how we do it. Sorry if I bump into you coming back here. It's just, you know, this room is dumb. Sorry about that. If I had a way to knock the walls out and make it bigger, I would, you know? Or to like lower the seat count in here, that would be helpful, right? It should be about 5 lower at least, right? Something like that. So if I'm going to solve 3x minus 7 equals to 1, think about this. There's 2 ways that could happen. 2 ways, right? The one way would be 3x minus 7 equals to 1. What's the other thing that could happen? You could have 3x minus 7 equals to minus 1, right? If you have either one of those equations hold true, you've solved the problem, right? Because it would plug back in and solve the original equation. Can we solve those equations? We can, right? So let's do it. So add 7 to both sides, we get 3x equals to 8 here. Add 7 to both sides, we get 3x is equal to 6 here, I guess, right? So what's x equal to? X is equal to 8/3, or x is equal to 2. Right? There you go. Point of order on the next, you know, test or quiz on this stuff. If you have an absolute value equation and you don't get 2 solutions, and it's like it's this pattern, then you probably should think about, wait a minute, I'm missing something, right? Yep. Well, the absolute value can be plus or minus, right? So if you want to, we could write it this way instead. We could say, or minus this equals to 1, if you want to think about it more in terms of like direct logic. It's because the absolute value is either the plus the thing in it or it's minus the thing in it. But then I moved the minus to the other side. So does that makes more sense to you? Cool. But you see that it gives the same equation, right? So other questions? This is not on the Quiz Wednesday. The Quiz Wednesday is on the stuff we did last week. It's on like systems of 1 equation, 1 unknown, 2 equations, 2 unknowns, 3 equations, 3 unknowns, maybe a sample question about identifying slopes in a graph or parallel perpendicular idea. That stuff is what's the quiz tomorrow. Tomorrow, it's going to be Wednesday. It'll be at the end of class, so you can leave when you're done. Yep.
It doesn't pertain to this. If I had a slope that was parallel to another slope, line, the slope would be the same, correct?
Right, yeah. Parallel lines have equal slope.
But then if they're perpendicular, it'd be like the opposite.
Negative reciprocal.
Negative. So if it was positive 2, it'd be negative 2?
It would be negative 1/2.
Negative 1/2, okay.
Yeah, the product of the product of perpendicular slopes has to be negative. And the product of not just that, the product of perpendicular slopes is -1, because it's the slope times -1 over the slope, which should give you -1. So you have your 2, you have your -1/2, you multiply them together, you get -1. It should be that. Let's work something easier. How about this? Absolute value of 13,462x squared minus 13x plus 7, absolute value equals to -1. I made this extra snazzy, like this isn't even in section 1.8, but my point to you is you can put whatever you want inside that absolute value, right? But if you set it equal to -1, the answer is no. You can't do it. No solution, right? No solution. That's impossible. We can't have absolute value equal to a negative. All right? It can be that easy. All right? Let's look at another one. Are there always two solutions? Like what happens? Not always. So example 3. Did I ever move the camera over here? I did, yeah, okay. How about this? What if we had the absolute value of x minus 3 plus, I don't know, x equals to, let's say, 4. Now this one's different because we don't have absolute value. We got that x outside the absolute value, right? So this is a different kind of problem. But we can again attack it. There's two cases, right? Either the absolute value inside the absolute value is positive, or the thing inside the absolute value is negative. So those give us two different cases. We can solve them separately. So the positive case, this case, we have x minus 3 plus x equals to 4. The other case would be what? Absolute value of x minus 3 equals to minus parentheses x minus 3, right? In that case, we have minus parentheses x minus 3 plus x equals to 4. Can we solve these? I heard a yes. So you got what? 2x equals to 7. So x equals to 7/2. Woohoo! All right, so solved. Yay. How about the other one?
Cancel.
What happens?
Negative x cancels out.
The negative x cancels, and we get what? We get 3 equals to 4. That will not do, right?
As long as you have one case that works, you're good.
Well, yeah, we do. The thing is, we just have one solution. The other case doesn't give us a solution. All right. So apparently, when we're working problems with absolute value equality, we can get two solutions. We might get no solutions. We could also get one solution in a problem like this. Let me just, now what I'm about to do is not part of the material that's currently tested, but I think it's helpful for you to understand like what's going on. So we come back, we test the material I'm about to share with you later in the course when I talk about graphs of functions. All right, so if you don't know what I'm doing, what I'm about to do, it's all good. But this problem up at the top, right, it's equivalent to absolute value of x minus 3 is equal to 4 minus x. I think we can all agree with that, right? So one way of understanding the equation that we're solving is we're really looking for where y equals to the absolute value of x minus 3 and y equals to 4 minus x, where those have solutions. We've thought about this idea with lines, right? Two lines intersect at the place where both lines have their equations being true. Well, we can also look at this way if we knew how to graph absolute values. And again, I'm not testing on that yet. I'm just sharing it with you. Okay, we'll test on that later. So what's the graph of y equal absolute value of x minus 3 look like? Well, that's the absolute value function, which by the way is a v. It's just a v, and it's based at 3 here. So it's something like this. So this is 3 actually. This is also 3. All right. And what's y equals 4 minus x look like? It's got a y-intercept of 4. It's got a slope of -1, right? So its y-intercept is 4. Its slope is -1. So it's parallel, and it keeps going. So you can see what happened. Why it is we just got one solution. You see what happens? We cross the graphs at that one point. That's where we got the 7/2 solution from, right? Like right here. This happens at x equals to 7/2. But on the other hand, there is the other case, right? The reason there's no solution is because these lines are parallel. They never cross. There's no other solution over there. If you threw in a number, right? If I like multiplied the x by 2, or if I multiplied the inequality by 2 or something like that, they would have different slopes and they'd end up crossing somewhere where you get two solutions. But this is why sometimes you just get one solution. That's the geometry of what's going on. Again, if you don't, this is right here, this whole box is time travel. It's we're traveling in time to a time after test 1 when we talk about graphs of functions and things like that, okay? That's later in this course. So up till, I don't think I introduced function until like, oh man, I forgot my course schedule. All right, anyway. I sincerely hope I don't have to retract these comments next class after I look at my course schedule and am reminded by the fact that I'm forgetting about which semester I'm in or something stupid, but hopefully these comments are right. I did design the course after all, but I did it like a couple months ago, you know? All right, any questions? Yep.
So if there's two x's, you're just solving for where the lines intersect?
Geometrically, yeah, I think that's what we're doing. But as a practical matter, all you have to do is put the absolute value positive, the absolute value negative, and solve those things separately, and whatever happens, happens. Does that make sense? These don't have to be hard. Remember, though, you could have two solutions. If you just drop the absolute value and pretend like it's just nothing, nothing to see here, I'll just ignore those little vertical lines, just drop them, solve it, you're missing half the answers. You're going to lose half credit for the problem, right? Like problem number 2, example 2, if this is on a test, and you just give me x equals 8/3, well, that's lovely, but that's only half of the problem, right? You lose half credit by just giving me this, because you've missed half of the problem. Although you still get half credit. You know, there's partial credit, thankfully. All right, let us move along here. So I said today was mostly about absolute value. That's almost true, but now we must begin our discussion of the dreaded topic, inequalities. So, yes, inequalities. It has come to that. It is time for us to discuss inequalities. And, you know, I'm not going to try to sugarcoat it. Inequalities are difficult. They're like way more difficult than equalities, and they require a little bit more care. So, but the basic strategy with inequalities is the same. We're trying to isolate x, right? And once we isolate x, we can understand the solution. That's pretty much it. So I've lost track of my example number. My bad. Example 4?
You're on example 5.
Example 5. Cool. Thank you, sir.
Anytime.
So let's look at 3x minus 1 less than 7. Can we solve this inequality?
Yeah.
Right. How do we do it? What do we do? Add 1 to both sides. Very good. Which gives us what? 3x less than 8. Then we can do what? We can divide by 3. Right? It's allowed. X is less than 8/3. So that means that the solution is minus infinity, comma 8/3, not included. See, because in terms of a number line, right, if you put 8/3 on here, x has got to be like over here, right? So that's the solution if you want to think about it in terms of like a number line. I usually ask for the answer for an inequality in terms of interval notation. So the interval notation is right here. This is interval notation. Of course, you can also ask for the answer in terms of a number line, but I usually ask for interval notation. Yep.
When will it be a bracket? Like instead of an 8/3, when will it be a bracket?
So let's look at an example where a bracket comes up. Example 6. Let's look at, say, 8 minus 2x greater than or equal to, well, let's say less than or equal to 10. That will answer your question. Now what? I subtract 8 from both sides, right? If I subtract 8 from both sides, I get minus 2x is less than or equal to 2, right? Then what do I do?
Divide by -2, but then when you divide by -2, you have to flip the sign.
I divide by -2, but when I divide by -2, I have to flip the sign. Music to my ears. So let's not write the division on what we already have. Let's write a new line. Minus 2x divided by minus 2 is greater than or equal to 2 divided by minus 2, right? Let's not try to divide by a negative number on the inequality that we've already written. It just invites disaster. New line of math. Don't try to add to your previous line, because the direction of the inequality has to flip-flop. Like what was your name?
Sammy.
Like Sammy was saying, right? So Sammy is correct. And this gives us what? This gives us x greater than or equal to minus 1. Now, personally, I find that to be, like I mean, that's fine. Greater, we can write greater than or equal to. If you draw a number line here, what's it look like? If this is minus 1, where's x? X is greater than or equal to minus 1.
It's going to be an open circle. Column 1, -1.
It's a closed circle because minus 1's included this time. But where is x? My question is x on the left or the right of minus 1? It's on the right, right? So x is like over here. So see, that's the thing about the number line and greater than. See how the pattern, you see the patterns against it? So if you want the pattern of the number line to match the pattern of your inequalities, you need to write things in terms of less than. If I write this in terms of less than, this is what? This is minus 1 less than or equal to x. See, if I write that in terms of a less than, then that is in, it's in the same pattern, the same left to right reading as the number line. Personally, I make less mistakes if I write everything in terms of less than. But you can think about less than, you can think about greater than. It's totally fine. The point is, the solution is over here, right? It goes on and on. So the solution here, solution set is equal to, now minus 1 is included now because we had the equality. So that means minus 1 is in the solution set. And it keeps going and going, so infinity. So there you go. That's the solution in this case. I'll take a breath. Any questions? Now, I think this is in like an earlier section. This is not in section 1.8. Section 1.8 is just all about absolute values and absolute value inequalities, which we're going to talk about. This is before that, right? So I just thought it would be healthy for you guys to have a review of these basic ideas before we get into like the snazzier absolute value inequalities, which require some care. They're not that hard, but you have to pay attention to where you are and what you're doing. So example 7, we're not quite there yet, though. One more example here. So how about I have 3 plus x less than 2x minus 3 less than or equal to, x plus 8. All right, so hopefully I've written a reasonable set of inequalities. Every so often, you can just write down a set of inequalities which are logically impossible. It's not that hard to do, right? Like you could search for a mate, for a significant other, whatever you'd like to call this person, that enjoys eating at like McDonald's and Burger King. And like maybe that's impossible. Like, let's see, now you need to come up with more dissimilar restaurants, like Bojangles and Kentucky Fried Chicken. Like maybe you can't find that person. No? You guys are dead. Let's see here. I need to come up with something more ridiculous.
Starbucks and Dunkin'.
Starbucks and Dunkin'. That's pretty good. I like that. That's okay. Starbucks and Dunkin'. Domino's and Papa John's.
Papa John's and Chick-fil-A.
How about this? How about La Coretta and what's the other one that I never go and eat at? What's a La Coretta? How dare you, sir?
They're actually pretty new to Lynchburg.
La Coretta and Mi Patron. Like there's some people like the Mi Patron. These are the two major like local Mexican chains around here. But La Coretta's, I think it's pretty good. If you want to eat La Coretta food for like 3 times the price, you can go to Papagayo in the mall. That's the fancy place across from the theater. Anyway, all right, so I digress. So our goal is still to isolate x, right? So I would suggest the first thing to do here, subtract x across of it, right? We subtract x, see what happens? Something nice, yeah? So if I subtract x, and if you've got a compound inequality, which is what we have here, you have to do the same thing if you're doing adding or subtracting. You have to do the same thing across the board, right? But if you do, that's an allowed operation on this so-called compound inequality. Now that gives me 3 is less than x minus 3 is less than or equal to 8. And then what do I do? Subtract 3 is almost right. How about, what do you want to do? Let's add 3, right? Because we want to isolate the x, right? So adding 3 gives me 6 is less than x is less than or equal to 11. So what's my solution set in this case?
X is a number between 7 and 11. Well, it's also 11.
Right? So on the number line, it looks like what? Here's 6, here's 11. 11 is included, 6 is not, x is in here somewhere. In interval notation, what do we got? We've got, yeah, parentheses, 6, very good, comma, square bracket, 11, right? That's the solution set here in interval notation. Is good? They want to have like pet snakes and pet lemurs. I don't know, like you need something. I guess the person who wants a pet snake might also want a pet lemur. Like he's part of a larger like way of living, wasting time on exotic animals, right? Cats and dogs. I have a student who went to school, grad school, somewhere, and they were telling me something funny. They were like, in all their classes, they have to introduce their name and their pronouns. And he's like, and then the professor was asking them to talk about their cats, and it's the weirdest thing. People have no trouble gendering cats. Like, there's no confusion. There's no gender confusion with the cats. It's always like a he or a she. There's no like, this is my cat, and their pronouns are like, you know, they, zay, or whatever we do, meow, meow, and liver. I don't know, like, what do you make of cat's pronouns? I don't know. If you guys can figure it, meow, meow, and chow, chow. You guys can figure this stuff out. You're doing better than I am. Yes, we still have time. So I need to share with you the fundamental lemma. Let me write it over here. So let's have a discussion here before we do any more inequalities. And it's a relatively simple discussion, but please follow me. So if we say that the absolute value of A is less than D, where D is some distance, where does that put A on the number line? Think about it, right? This is my number line. This is 0. This is D. This is minus D. Where does A have to be? Yeah, it's between, it's either here, right, like you said, or it could be over here, right?
Wouldn't it just be any distance between negative and positive?
It'd be any distance.
My point is, if I have this condition, that means that the distance from the origin to A is at most D, right? That's what that means.
Oh, wait, no, I see.
So what does that mean in terms of a compound inequality? See, this is equivalent to minus D is less than A is less than D.
It would be the same thing.
I'm just noticing that spells dad. It's kind of awesome. I usually use like a delta here. I'm depriving myself of this stupid dad joke all this time. I think that's appropriate. So this is the one case. But what is the other case? The other case is you could study the absolute value of A is greater than D. What would that mean in terms of the number line? Here's minus D, here's D, here's the origin in between them, right? Where does A have to be in this scenario?
Wouldn't it be past D?
It has to be past D, or what? Yeah. So like over here is what you mean, right? It's like it could be over here, anywhere out there would be fine, right?
Or it would be past negative D?
Past negative D, right? That would also put your point A distance more than D from the origin, right? This means that the distance is more than D from the origin. Okay? And so that means that this is equivalent to a pair of inequalities, namely that A is less than minus D, or A is greater than D. So let me write it down again for our reference. Fundamental lemma, absolute value of A less than D is interchangeable with minus D less than A less than D. Absolute value of A greater than D is interchangeable with A less than minus D or A greater than D. And so that's the fundamental lemma that will guide our solving inequalities involving absolute value. We should always come back to this and use this, all right? This belongs on your formula sheet, along with a pair of examples, one for the less than case, one for the greater than case, so you make sure you get it, all right? Let's solve some example. Let's solve some problem. I'm on example what? 8. So what if I'm up against the, aw man. You know what I did?
What you did?
What I didn't do?
You did a corner.
I didn't go over there, did I? I surely didn't.
No, you didn't.
Man,
We're gonna start reminding you.
I'm sorry, people who weren't here. You should probably watch, well, I don't know. This is what I just was talking about. If you're closer than D, you're between plus or minus D on the number line, which is this condition for A. If you're distance more than D from the origin, that means you're either before minus D or after D, which means you've got this conditions on A. So let's apply this idea to an example. What if we're up against, I don't know, 7x minus 1 absolute value less than 10? So how do we solve this problem? Let's think of it in terms of a substitution, all right? Think about this being quote unquote A, right? And so this is equivalent to what? Minus 10 less than A less than 10. But what is A? Right, so we're really up against minus 10 less than 7x minus 1 less than 10.
10 and 1 to 10?
No, this is not. This is an inequality, though. I can't just. It's not. If it was equals, I'd solve with the 10 and minus 10. But here we're trying to find all x that satisfies the inequality. So the answer should be like an interval, or maybe a union of intervals. But let's see what happens. So if we add 1 across this, we get what?
9
Yeah, minus 9 less than 7x less than 11. And then do what?
Divide by 7.
Divide by 7. Minus 9 sevenths less than x less than 11 sevenths. So my solution is minus 9 sevenths comma 11 sevenths. There you go. There's the solution in interval notation. That's it. We're done. We solved this problem. Those are the x which solve this inequality between minus 9 sevenths and 11 sevenths as it happens. How about if instead of putting less than, we put greater than or equal to? So example 9, and I'll stick with the same pattern. Suppose we have absolute value of 7x minus 1 greater than or equal to 10. How's that go? I won't even write down the a, but think of the 7x minus 10 like the a in the lemma, right? Apply that idea. What are the cases? We've either got 7x minus 1 less than or equal to minus 10, or we've got 7x minus 1 greater than or equal to 10. So I'm also noticing something. If I have equality, you just throw equality in. All right, the lemma is still true if like you, here I'll color code it if you guys don't mind. And I see I've already set myself up for the fall. I guess I just need to work in the center board and then I won't have to think about it, right?
You should get one of those cameras that follows you around with you.
I've got one of those things. Like a student got me for one of those, but you gotta like do this all the time, like make like this L for like loser, and like it just doesn't seem friendly. And I've had not really good results with it, honestly. Not to mention, like, capturing board work at the speed that it's written decently is something you need a relatively high-end camera to do. That's the lowest kind of camera you can get away with and do decently on this. But anyway, I digress.
Maybe you can use 3 cameras.
Use 3 cameras?
One for each board.
Well, maybe. I don't know. Someday we'll start charging students a technology fee so we can afford these sort of extravagances. But
Please don't. These cars are so expensive to come here.
I know, I'm just joking. Okay, so we add 1, right? That gives us 7x less than or equal to minus 9, 7x greater than or equal to 11, which means x is less than or equal to minus 9 sevenths, which means x is greater than or equal to 11 over 7. So in other words, x is in minus infinity to minus 9 sevenths included, or x is in 11 sevenths included to infinity. These two cases are disjoint. There's no commonality between them. They're separate. It's a solution in this case, for example 9. Solution set minus infinity to minus 9 sevenths included, unioned with 11 sevenths included, that's the square bracket, to infinity. And there you go, that's the solution set in this case. Have you guys ever heard the term complementary? Do you know what that means?
All angles add up to 90.
You're like free stuff, or the angles add up to 90. That's very good. That would be a logically separate use of the word complementary in mathematics. You're absolutely right. But the complementary here I'm thinking of is like logical. Like the complement of this set in the real numbers is that. The complement of this set in the real numbers is that. In other words, every real number which is not in here is in there. And every real number which is not in there is in here. Why is that? It's because these problems are related, right? I solved the inequality 7x minus 11 less than 10. I solved the inequality 7x minus 1. I said 11. I should say minus 1. 7x minus 1, absolute value less than 10. Absolute value of 7x minus 1 greater than or equal to 10. These are disjoint cases, but either 7x minus 1 is greater than 10 or it's less than 10, right? It's either or. So that means that whatever x is, it has to fall into one of these two cases, which is why the solution sets for these two problems, if you put them together, they give you what? Everything. So if you study my tests from previous years, you'll notice that I sometimes ask a pair of questions which are complementary. So that if you notice this pattern, you can check yourself. You know, is the answer for one and the answer for the next one, are they related? Because you should be getting everything if you're doing it right. The common mistake people make here is that they pretend that this is solved the same way as the other one. And it's just not. The greater than absolute value problems are very different than the less than absolute value problems. All right? You have to solve them in the way I've showed you. You can't confuse the methods. There's an asymmetry here. It just is. And any questions?
I wonder if you could like swap over, like, okay, I remember you saying earlier that you often do things in the lesson. So I'm wondering, right? This isn't really a confusion, it's more so curiosity. By swapping it over for, let's take example 9. It's a greater than or equal to. Think? Yeah.
Yeah.
So if you swap that around to a less than and solve it that way, you can get those answers and you can just swap them down to get the answer to the other one.
This is very true. You could always do this. You could take the greater than problem, you could invert it to the corresponding less than problem, find those answers, and then everything that's not your answer is your actual answer. That is a totally legit way of solving these, and I would respect it if you complete the thought and don't forget about it halfway. Because when you forget about it halfway, it just looks like you don't know what you're doing, right? But if you did it all the way through like that, not only would I respect it, I would be impressed. Like, that's a really smart way to do it, because you're right, like that is easier than this, right? Yeah, that's a neat idea. I never thought of that. Hey, cool, thank you. Bonus point, email me. If you make me think of something I haven't thought of before in college algebra, I give you a bonus point for sure. So, yeah.
Have you ever thought about unicorns on hot dogs flying in outer space?
Dag nabbit. Email me. You also have a bonus point. That's the end of the bonus point policy. I see that I have to amend it. Yes. It's too late for you.
I have something, but then
You got it. You had to beat her to it. But anyway. Dang it. I mean, I'm logically bound. I can't undo it. All right. Anyway, any questions? That's pretty much all I got for today. So, let's call it a day. Thanks, guys.